Apple Intelligence does not operate solely on the device. Every request distributes labor, moving data between the local neural engine and remote Apple Silicon servers. These servers form private cloud compute, a security-hardened environment designed for AI workloads that exceed the processing power of a handheld device. This architecture creates a coordination challenge. Even the most capable AI model fails if the underlying compute, connectivity, and application services do not respond in sync. Requests often stall or fail due to physical constraints, like network path congestion, storage contention, and variable latency. While Apple controls the silicon, the OS, and the services, the system lacks a predictive fabric to manage how these layers interact in real time. To prevent service degradation, a control layer must sit above the hardware, identifying potential resource bottlenecks before they impact the user. A single AI action moves from user intent through device intelligence, connectivity, the cloud, and security, triggering an application response. Integrating PTCP creates a predictive quality of service layer. It binds these nodes into a single fabric, managing the chain as a unified process. This coordination must happen while respecting Apple's privacy model, which means managing the handoff between local and cloud resources without ever inspecting the user's content. This integration allows Apple to fully coordinate its fragmented hardware and cloud elements into a single, predictable system. Every time you interact with Siri, your device makes a routing decision in milliseconds. The system must choose between executing locally on the neural engine or sending to private cloud compute. Local execution is limited by physical factors like thermal state and battery life. The cloud path introduces external variables, network congestion, server queues, and model loading times. The PTCP AI Factory module manages these variables through predictive telemetry. A slow path mechanism monitors the system over time, learning the baseline patterns of how different workloads and dependencies typically behave. This enables a bounded fast path that applies those learned policies instantly, routing requests around predicted congestion to maintain response times. Beyond the technical performance, this predictive routing changes the underlying economics of Apple's AI infrastructure. By reducing failed requests and minimizing P99 latency, Apple lowers the total compute resources required to complete a single task. Predictive routing also reduces the need to over-provision server capacity for peak demand, allowing for higher productive utilization of existing hardware. This efficiency leads to a measurable decrease in the infrastructure cost per AI request. Since server-intensive features are tied to iCloud plans, lower operating costs allow Apple to deliver more intelligence per unit of subscription revenue. The AI Factory module ensures that private cloud compute can scale as a high-margin services business rather than a capital-heavy cost center. As AI agents gain the ability to operate across applications, they create new infrastructure-level security risks. Apple faces a paradox. They must govern Siri's actions, but their privacy mandate prevents them from inspecting the data the agent is actually handling. Private cloud compute requires processing remains stateless and immune to content inspection by the infrastructure provider. PTCP resolves this by securing the system through operational metadata. It ignores the encrypted payload and focuses on signals generated by the request's behavior. The system monitors approved points like service relationships, timing, queue behavior, and cryptographic attestation state. This telemetry enables topological containment, a security model managed by the PTCP zero-day module. The system establishes an authorized topology of how Siri is permitted to interact with specific applications and data sources. If a compromised agent attempts to create an unauthorized network relationship with an unknown server, it creates a topological deviation. The system detects this instantly. It doesn't need to understand the prompt to see that the agent is trying to go somewhere it isn't allowed. PTCP can then automatically sever the connection or completely isolate the affected service to immediately prevent any potential data exfiltration. This containment sequence occurs without the system having to decrypt or inspect the user's personal content. While traditional security focuses on identity, infrastructure boundaries provide a secondary defense against misbehaving agents. Payload-blind containment allows Apple to increase Siri's agency while strictly maintaining the absolute anonymity required by the private cloud compute model. The requirements for predictive QoS and containment also apply to large-scale enterprise environments. The ACISO module extends these capabilities to Apple Business and mobile device management. ACISO creates digital twins of entire device fleets, allowing organizations to run predictive risk analysis and simulate the impact of security changes before deployment. For Apple, this opens new recurring revenue streams through enterprise-grade fleet assurance and compliance subscriptions. The framework also extends to physical interaction through the Siri AI module. Siri AI governs edge AI workloads that require the coordination of multiple physical sensors in real time. This supports hardware like iPhone LiDAR, Vision Pro sensors, and Apple Watch telemetry, where the timing of sensor fusion is critical for safety and accuracy. Siri provides a strict framework for developers to prioritize sensor data and set hard boundaries for AI-driven physical actions. Extending the control fabric here creates a verifiable edge computing network across Apple's entire hardware ecosystem. Incorporating a predictive control fabric allows Apple to consolidate its integration across all growth engines. It also changes Apple's relationship with its hardware supply chain. By placing a predictive policy layer above third-party components, Apple gains direct telemetry on how wireless silicon handles AI traffic. This data allows them to define precise requirements for future custom chips, reducing their long-term reliance on external supplier roadmaps. This technical integration powers the shareholder value flywheel. It begins when a more reliable and private AI experience drives increased demand for hardware upgrades to AI-capable silicon. As more capable devices enter the market, user engagement with Siri, iCloud Plus, and Apple's broader services increases. That increased scale, combined with predictive routing, drives down the infrastructure cost for every AI request handled in the cloud. The result is higher service margins and increased ecosystem retention, which allows the entire cycle to accelerate. Acquisition ensures Apple maintains exclusive control over this roadmap, preventing proprietary infrastructure data from being exposed through third-party licensing. Apple's brand is built on privacy. A predictive control fabric is the engineering requirement to make that privacy economically predictable across a billion-device network.